Hello everyone, we'll discuss properties of hydrogen in today's video. So, talking about the properties of hydrogen, first we'll discuss the physical properties of hydrogen. Hydrogen exists as H2 gas in nature. It is colorless, it is odorless, it is tasteless. It is combustible gas, that's why H2 when burnt with oxygen release H2 as a byproduct along with energy. Okay, it is lighter than air and it is insoluble in water. Okay, now talking about the chemical properties. Chemical properties are basically chemical properties. How will you define a chemical property? Chemical properties when they depends upon the bond enthalpy between this hydrogen and hydrogen bond. It means how strong this bond is so that this hydrogen can react with different compounds. So the HH bond enthalpy for hydrogen is highest for the single bond. For the single bond compounds like for FF or chlorine, so such single bond compounds that are available in nature, for among all, HH bond is the highest, has the highest bond energy. So in order to break this HH bond, if you apply 2000 Kelvin, then the bond breaking would is only 0.081%, while if you apply 5000 Kelvin, the bond breaking is up to 95.5%. It is not like if you increase the temperature, the bond breaking, the percentage of bond breaking increases linearly. It's not like that. If the curve is linear, then only we can expect that if it is at 2000, then maybe at 4000 it should be doubled. But it is 95% and it is not even 1%. So it is not like that it is following this curve. It is not following this curve, it is following some other curve. Some other dependence is there. It is not linearly dependent. So, since we are talking about the chemical properties, how does a chemical reaction happen? Chemical reaction happens when there are exchange of electrons. So, of electrons. So, how can a hydrogen molecule react? Hydrogen has an electronic configuration, one hydrogen atom has an electronic configuration of 1s1. So either it can react by the losing one electron to form a H positive ion and donate its one electron to some other compound, or it can gain one electron to form hydride ion, or it can share this one electron in its 1s1 configuration with some other element to form a covalent bond. So we can say that hydrogen can react in three ways. One is it can lose one electron to form H positive ion. Hydrogen can react in three ways. It can lose one electron to form H positive ions minus electron. It can gain one electron to form hydride ion, or it can share its one electron with some other element and form a complete its doublet. Okay, one electron for hydrogen, one electron for some other bond, and a covalent bond is between. So covalent bond formation. So starting with the halogens, how does it react with the halogens? As we know that halogens contain what is the electronic configuration of halogen? We represent halogen with symbol X. So halogen has an electronic configuration of Ns2 Np5. So there is one electron less than normal gas configuration. So it could be like if it is forming a ionic bond, it could be like that hydrogen is donating its one electron to form H plus ion. And on the other hand, some halogen like fluorine, let's say, is gaining this electron to form F minus, and there is an ionic bond between the two. If it is an ionic bond formation, or if it is a covalent bond kind of thing, then it could be like hydrogen has one electron or halogen has one electron. Both are reacting and X is completing its octet or hydrogen is completing its doublet, and both are forming HX, a covalent bond. So that's how it reacts with the halogens. Reaction talking about now how it reacts with dioxygen, that is O2. As we have seen that hydrogen can react with oxygen. In burning, when we use hydrogen as a fuel, it burns in the presence of oxygen and releases energy. Now the thing is, if hydrogen is burning, since it is present in nature, nature has hydrogen, so nature also has oxygen. If this reaction can happen so easily, then we should not have oxygen in the nature to breathe. All the hydrogen present in the nature should have reacted with this present in the nature, so that we would not have any oxygen to breathe. This reaction happens only when you apply harsh conditions like strong heating or apply some catalyst. Then only hydrogen can react with oxygen, otherwise we won't have any oxygen in the air to breathe. All the hydrogen must have reacted with the oxygen. So for this reaction, some catalyst or heating is required. Here the delta H for this reaction, enthalpy of the reaction is negative. What does negative enthalpy tells? Negative enthalpy tells that the reaction is exothermic. Exothermic means energy is released. Energy is released. That is the reason that hydrogen is used as fuel, because energy is released and this energy is utilized for other purposes. Now talking about the reaction with dinitrogen. In reaction with dinitrogen, nitrogen has basically 3 electrons in its p orbital. So what is the electronic configuration of nitrogen? Electronic configuration of nitrogen is ns2 np3. Okay, it has 3 electrons in its p orbital, singly filled 3 electron. Okay, so 3 such nitrogen molecules react with one molecule of nitrogen at this temperature 673 Kelvin and 200 atm pressure in the presence of iron as a catalyst to form ammonia, and this process is called Haber process. Why is this, like, why have they defined this temperature, pressure and catalyst in this reaction and even named this reaction, this process? Why it is so important? This process is important because of the formation of ammonia. Ammonia is utilized in the nature and it has very important, it is very much important. Why? Because of agricultural point of view. Agricultural point of view. Ammonia is used as fertilizer. It was very important during the time of Green Revolution. So basically the process is so much important that it is used in our daily life, and it for very important purpose, that is agriculture, growing food. We are dependent on crops for our food, so it acts as a fertilizer and it is very important. That's why the reaction has been given a name, that is every reaction has given be a name after the person who produced that reaction or generated that reaction, found that reaction. So but this reaction has immense importance because it produces a product which we use as a fertilizer for our very useful purposes. We are very dependent upon this one. So you must remember that condition of temperature and pressure, and the catalyst used in this process is iron. Okay, now talking about the reaction with metals. Till now we have discussed that how hydrogen reacts with halogens. Halogens has one unpaired electron, so hydrogen can either lose one its electron to form an ionic bond with halogen, or it can share to form a covalent one. Now talking about how does hydrogen react with metals. We have discussed reaction with dioxygen, nitrogen and halogens. Talking about metals, since we know that metals are electropositive in nature. Just a second. So metal electropositive means metals has a tendency to lose electron and form M plus ion and E. Electrons are released. So metals are electropositive in nature. So if metals are more electropositive than hydrogen, sorry. So since metals are more electropositive than hydrogen, so these will lose the electron and hydrogen will gain this electron to form H minus. So generally, if hydrogen reacts with metal to form hydrides, metal hydrides. Okay, so depending upon, since these are generally formed with the alkali metals are more electropositive, since if the alkali metals has electronic configuration of ns1, so if they lose one electron, that they will do easily to attain a noble gas configuration, so that they have zero unpaired electron, and they will attain a noble gas configuration. That's why they have are very electropositive in nature. So for alkali metals, two such metal ion will be required to react with one molecule of hydrogen to form two molecules of metal hydride. Now reaction of with metal ions. Let me just rub this one. So reaction with metal ions. Metal ion, as I have already said, if they are alkali metals, then alkali metals has a tendency are electropositive. They will lose that electron. Alkali metals will lose electron to form ion, and hydrogen will gain this electron to form H minus, and this will combine to form metal hydride. Now, if metal ions are present and these are of like D block element, D block element. So these D block elements actually can we study no that hydrogenation reaction. If we want to convert some such unsaturated bond to saturated one, we use catalysts like palladium, platinum. So why do we use these catalysts? These catalysts contains voids in their lattice. Lattice is basically a 3D space occupied by metal ions. I'm sorry, let me just change it. Okay, 3D space occupied by metal ions. So if it's a lattice like this, let's say metal ion present at this distance, and this is the specific distance in the lattice. So if this is the void between these circles are the metal atoms, and let's say this is the void between the atoms. So in case of d block elements, when we use such metals like palladium, these has these voids in this lattice, and they can trap hydrogen inside these voids. That's why they are used for these hydrogenation purposes, So we can say also say that if we are using some palladium or some other metal and d block elements, so they can react with the hydrogen, where hydrogen will lose its electron to form to give hydrogen will lose its electron and will convert into H plus ions, or it can also react with the metal oxides. Now reaction with metal oxides is very important. How? In nature, how do we extract metals? How metals are extracted from earth? In earth, metals are present in the forms of ores, and those ores are generally metal oxides. So those ores or minerals are metal oxides. So hydrogen gas is used to convert metal oxide, that is ores, to gain metal from earth, and water is released as a byproduct. So in the process of metallurgy, that is the science. Metallurgy is, let me just rub it. It's just too much on the screen. So metallurgy is the science where metals we study how metals are extracted from the earth, and in earth, where is my cursor? Okay, here. Metallurgy, Lurgy, is the science of extracting metals from ores. Ores are basically metal oxides. So hydrogen reacts with such metal oxides, let's say MXOY, and it reacts with them, and it what it does, it gives its electron. If hydrogen will release its electron, let's say it is M plus Y and O minus X. So this metal ion will gain those electrons to convert into metal solid. This metal ion will get reduced after gaining electron, while hydrogen will lose its electron to convert into H positive ions. That's how we extract metal from the earth's surface, and whenever hydrogen will react with any metal ion, it will donate its electron and convert into H plus ions, and that ion will be reduced to metal. How does it now coming to the how hydrogen reacts with the organic compounds? Sorry for the disturbance. Hi, so we are discussing how reaction happens with the organic compounds. As we know, very important reaction is the halogenation of unsaturated organic compounds. We have heard from our previous classes as well that vegetable oil contains unsaturated bonds like C double bond C. Alkenes and alkynes are basically unsaturated hydrocarbon. Alkenes and alkynes. You must be aware of this. So we have heard that hydrocarbons are of three kinds. Generally, non-aromatic hydrocarbons or aliphatic hydrocarbons are of three types: alkanes, alkenes, and alkynes. Alkanes are basically saturated ones that contain single bond. Alkene and alkynes are unsaturated ones where there are presence of double bond and triple bond. Okay, so these vegetable oil that are present in nature, these are basically oil, any oily thing, let it be refined oil that we see, the vegetable oil, basically these are liquid in nature. Okay, liquid, these are unsaturated, these contain double bond or triple bond, but when we use hydrogen in the presence of catalyst nickel, these double bonds are reduced to single bond, and once it get converted into single bond, they might get solidified. Okay, that's why we see ghee as the solid one and the vegetable oil as liquid one, and this is very important reaction, the conversion of vegetable oil into ghee. And the other one, for the reaction with the organic compounds, we can say that for hydroformylation. Why we are saying that is hydroformylation? Hydroformylation means you are adding hydrogen, as well as formylation means you are adding a formaldehyde. Formaldehyde is the primary first aldehyde, that is HCHO. So basically you are adding forming a aldehyde as well as you are adding hydrogen. So that's why the reaction is hydroformylation. So if any unsaturated alkene is taken, hydrocarbon is taken, let's say any alkene, in the presence of carbon monoxide and the presence of hydrogen, hydroformylation occurs and it forms aldehyde as other product, and if further reduction occurs, the aldehyde it will be converted into alcohol. So these are the two examples where the we can say how it is reacting. So till now what we have discussed that just a second, let me add a page. So today we discussed properties of hydrogen. Properties of hydrogen. We discussed the physical properties. It is tasteless, colorless, odorless. We discussed all those things, and it is lighter than air and all that thing. So we discussed about the physical properties. Chemical properties are basically that define its chemical reaction. Chemical reaction basically depends upon the transfer of electron. So how hydrogen can react? Hydrogen has 1s1 electronic configuration. Either it can gain one electron to form H minus ion, where its electronic configuration will be 1s2. It has a tendency to lose one electron to form H plus, where its electronic configuration will be 1s0. Or it can share its one electron, hydrogen, this is the hydrogen of electron, and any element which has this electron, so that they can share this electron via the covalent bond and form a covalent bond. So there are three ways where hydrogen can react, and starting with we discussed how it reacts with halogen. Halogens are represented with the X symbol. Any halogen is represented with the X symbol. Halogen has an electronic configuration of ns2 np5, which is one less than noble gas configuration. So if hydrogen is reacting with halogen, either it can lose its one electron, let's say H will lose one electron to form H plus ion. That electron will be gained by halogen to complete its octet. It has np5, no, it will convert it into ns2 np6. So it will may form H plus and X minus. Now its electronic configuration is ns2 np6 and its electronic configuration y is 1s0. So these are ions. It may react to form HX, or it could be like hydrogen has one electron, halogen has five unpaired electron, no, in its p. So it has five unpaired electron in its p orbital. I am just writing ns2p5, no. So hydrogen has 1s1, ns2 np5, it has electronic configuration. So this five electron, if they share this one electron with each other, hydrogen will complete its doublet, whereas the halogen will complete its octet. ns2 np, now it is np6, because it has gained one electron from this one. Reaction with we when now let's just talk about, we have discussed with this reaction with oxygen. We can say hydrogen will react with oxygen and can react with oxygen to form H2O with a it's an exothermic reaction. Delta H is negative for the reaction, and energy is released. That energy is utilized because of release of so much energy. That's why hydrogen is utilized as fuel. But this reaction can only happen when you apply extreme conditions of temperature or catalyst you provide. Reaction with nitrogen, this reaction is very important, as the product we get, it is ammonia will act as a fertilizer, which is of immense importance in our daily life. So the process is very important, that is Haber process. Do remember the condition of temperature, pressure, and catalyst for the process. Catalyst used here is higher. So now the reaction with the, we have discussed with the hydrogen metal ions. So with metal ions like palladium 2 plus, hydrogen can donate its electron to palladium 2 plus to convert into palladium solid product, and it itself can convert it into H plus ions. Or if you talk about metallurgy, science of metallurgy, where metals are extracted from metal oxides present as ores in the nature. So hydrogen can be used to extract metal from the earth crust, and itself can form H plus H2, can combine with this oxide, no, oxide, metal oxides, to form H2 as a byproduct. And also it is used to convert some organic compounds like vegetable oil that contains unsaturated bonds plus hydrogen in the presence of catalysts to form saturated ones, oil to ghee conversion. Yeah, that's what we learned in today's chapter: physical properties, chemical properties, how it can react, and reactions with different some reaction with different compounds. That's all for today video.